Thank you everyone for joining. Today we'll talk about CompletableFuture. My name is Dmitry Vinnik and I'm an open source developer advocate at Facebook. Before we start, just in terms of Q&A, I'll keep it to the end. So if you have any questions, please do ask them after the presentation. But I'm very much open to answering them after the fact. All right, and if there is anything, please do ping me if there's any issue with the audio or anything like that. Okay, so I always like to introduce myself. As I said before, I'm a developer advocate at Facebook. We're basically working with the open source projects that we have to empower diverse community through open source. We have a massive portfolio of different projects you can find on our website. I personally focus on mobile, and gladly I can deal with the Android. And so that's where I can use my Java skills and hence the CompletableFuture and things of that sort. I also deal with iOS and some hybrid projects that we have, like React Native. I work with Litho for Android, Fresco, and Flipper that covers debugging for mobile applications. But more importantly, I'm passionate about open source, and so that's why I'm actually contributing to the community by giving these sort of talks. And so without further ado, let's get this out of the way and actually start the presentation. So I always like to set up the goals upfront, so it kind of drives our agenda and you know what to expect. We'll basically talk about concurrency in its different forms that you can encounter in the wild. Then we will talk. Why is it? Okay. Sometimes it's like lagging. We'll talk about misconceptions of concurrency and what scares people away from it, and try to deal with those and basically break those misconceptions. And last but not least, we'll talk about workflows or asynchronous programming or CompletableFuture in more practical terms. All righty. Why do we need to deal with concurrency? Obviously, it's important to set the motivation. I've in the past worked with at the large organizations prior to Facebook even, and it was always fascinating to me that it doesn't matter what scale of the app you might have, you will try to avoid concurrency at all costs, which again, I'll try to cover why for the most part, but often it's because there's no motivation really for folks to even try. And the motivation, again, the fact that we currently have multi-core almost at our fingertips, right? Even the simplest laptop that you can get right now has multiple cores. You don't have to worry about dealing with resources and not have enough resources. We also have microservices. Used to be a thing of it used to be a hot topic years before. Now it's kind of accepted, and now people actually try to get away from them for some applications. But the reality is microservices really force you to think concurrency first. And also cloud computing services like AWS, Google Cloud, Azure, and many others. You can't complain and say that you don't have enough resources. You can buy them. You don't need to buy hardware anymore. You can just deploy it in the cloud. And obviously I have to bring this graph up to show how the price and the capabilities of our hardware has been increasing year after year. Ultimately, what I'm trying to say here, you have resources, not utilizing them is kind of wasteful. So the conclusion is obviously you can't just say concurrency is the new reality. Concurrency is the reality. It is a thing, not of the future. It is a thing of the present. So, but it's obviously still not convincing. The fact that you have those, capabilities, I doubt it will convince you right away to start giving it a try. And so the real benefit of concurrency is that, again, there is no idling because you have so many resources already and not using them. And it's very wasteful. It gives you better user experience. Long before when I tried to use like Java Swing in the past, and I would have a hanging thread when a user tries to cancel an operation. Today's customers, they are not to say spoiled, but they have expectations, right? They're not going to wait for your application to load. They would expect you to have a higher user experience. And also, whether you actually use concurrency or not, it forces you to think in very abstract terms and try to defend your code as much as possible from outside changes like race condition, locks, and things of that sort. So really, concurrency might sound great, but unfortunately, it's not just good parts. There are some complexities, hence we even have to talk about it to begin with. The thread safety is always an issue. How do you manage that? there are multiple threads or multiple procedures interacting with one another, accessing the same resource and not locking it, not having a liveness issue, how long that thread, how long that operation works. Imagine you kick off opening a file, but you never actually close it, or some other thread open it, but never closed it. That thread will still live, it will still consume your resources and might eventually break the whole thing. Liveness is definitely a complex thing to deal with. Is also obviously performance. You can't just expect that adding a second thread to your app that it has been single threaded will double the performance, will improve it twofold at least. It doesn't work that way. It's not that easy. And also it really makes it complicated on the entire software development lifecycle, all the way, not just development sake, but also testing. Testing, concurrency, concurrent threads is an issue of its own. So it is not trivial. So while it's complex, really, I would say it's still beneficial. That's why I've tried to kind of touch on a few points. And I would even say it's beautiful to some extent, right? To me, what it reminds of, and when I was reading a couple of books on concurrency, it reminded me very much about sharks, right? You're kind of afraid of them. They seem to be so scary and dangerous, but in reality, they're actually beautiful, right? They are great creatures that are roaming the wild. And so concurrency and sharks, they're very similar. When you're reading this book by Brian Goetz, Java Concurrency in Practice, it's the same approach initially, the same feeling you have. It's so complicated, it's so difficult. But if you read further, you actually appreciate the difficulty and how interesting it actually can be. The same if you, for instance, reading this book, Shark, Fear and Beauty, the same thing. It's so scary, they're so large, and especially now, since I have a new father, I've been seeing the baby shark a lot. So, it's you get used to sharks. The same way I would hope people get used to concurrency. So that's really the idea behind this presentation, is that we'll try to go from fear to admiration. Basically, start liking it, start believing in concurrency. And that's our agenda for today. We'll talk about single threading. It doesn't have to be Java specific, and it is not going to be Java specific. Then we'll talk about multi-threading. Again, not Java specific. So whether you are a Java developer or not, it will work for you. Then we'll talk about concurrency in Java. Since it's a Java conference, it does make sense. And lastly, we'll talk about workflows. The reason why I don't just say asynchronous programming in Java, it's because it's been inspired by workflows. It's been inspired by asynchronous coding elsewhere. And I also kind of just mentioned what is in the works right now, like reactive programming, and there are more things coming down the line. All right, single threading applications. Why do we even need to care about concurrency? I mean, I've talked about it extensively to this point. I don't remember what slide we're on, but I've been talking about for about 8 minutes now why concurrency is important. Some people will say it's too complicated. I like this approach of if your app is not broken, why to even try to change it, which is a valid argument. I would say whether you are thriving for concurrent development or thinking of adding additional threads, designing for concurrency is always a good thing. You basically try to avoid programming by coincidence. I never like those memes online where a person says it works, I don't know why. It's funny, but it should never happen, really. So there's never a coincidence why things work, because if there is ever not knowing exactly how things operate, concurrency will surface that issue, and some other thread will, maybe not close the resource or use it in a wrong way. That's why we try to strive for design by contract, where you have expectations upfront, what this function, what the method will do for you, and you know exactly what it will do. Try to avoid temporal coupling at all cost, meaning that when you have different stages of the operation that changes the state of the object. For a good example would be HTTP request. If you try to get a response from it before you actually call GET or POST on the request, whether you did invoke that GET POST, it will alter whether you can get the response from the same object. That's very much like the 101 of temporal coupling, expecting something just down the line the sequential way to change the object. You try to avoid that, actually. And instead, you're trying to strive for immutability, atomicity, which I'm not going to go deep in. Obviously, it's been covered by many other people, how to try to make immutable objects as much as possible. So, as to programming by coincidence, really, you know, if it's basically, you can say why it's broken. It really never worked. So sometimes, like even you have a test failing, you really don't know if it's actually worked correctly before, and that's obviously, I would say, a bad thing. For instance, simple date format. We often expect that it's supposed to be thread safe. I mean, it just formats the date, right? But in reality, it's not thread safe. And so you, until you actually dive into documentation, you would never know that. So, but you would have the expectations for no reason, really. And so if you were to unsafely format the data in a multi-threaded environment, it would break because one instance of invocation would alter it. A design by contract is basically, I really like this quote. It's require no more, promise no less, by the person who created wrote the book on the topic. And really, it's this example of a very simple example. You try to, sum two positive integers. You have a very validation exactly that you make sure that they are not nullable, and then you perform your operation, and then you validate the result. That way, you really enforce the contract. You're expecting that the non-nullable values, and you're expecting that it's going to produce a positive integer as well. So all of that is validated within the function itself. So you're trying to enforce the contract. Temporal coupling, the same thing I mentioned. It's kind of an example, if you are microwaving your, you have a microwave in the office or at home these days, and, you're trying to heat your meal that you maybe made the day before. You try to microwave it, but it actually doesn't do anything because in reality, microwave was never plugged. Try to put the food in, press heat, but nothing happened. It's because you haven't actually altered the state of the microwave and it hasn't been plugged. So you have to plug it first and only then interact with it. That's like, again, 101 of temporal coupling. You try to avoid that. Again, it's very abstract, obviously, and it's kind of fun. But let's talk about more complicated things, the multi-threading. What forms can it take, though? Different forms and different terms, and obviously it's arguable. But I think I'm going to follow the most common way to describe these forms. There is a concurrent form, there is a parallel form, and there's a synchronous form. And it's especially the first and the last one are the most important. The second one is kind of arguable. But let's look at concurrent form. So concurrency, it's really dealing with multiple tasks. They are logically happening at the same time, but they physically don't have to. Meaning that before it would be very important where you didn't have multiple cores, multiple CPUs. It will make it seem like it's doing two things in parallel. Let's say, or in this case, in this diagram, three things in parallel, but really just shuffling resources between each other. And it seems to be happening in parallel, but it doesn't have to. It's very abstract, obviously. Let's say we coded something and we're trying to develop an app. And what do we need to develop an app? We need coffee, obviously, and we need the laptop. So let's say we have someone named Henry. And Henry is, developer who only has really one line of focus. He can only do one thing at a time. And so he has to drink coffee, he has to code, drink, code, etc. And at the end of the day, he completed two tasks, and it seemed like he's done them in parallel, but he had to, shift in between. He can't drink and code at the same time. So it's basically how you would do it with the person. And that's how it would describe concurrency, I think, fairly well. In terms of parallel coding, okay. Parallelism, it's multiple subtasks, some people would argue, meaning you split this one task in multiples and then you combine the result. They physically have to happen in parallel, so they do require multiple cores. And in terms of simple diagram, you split one task, it's a good example would be some math calculations, right? You have two parts to the equation, you split them, you calculate them, you combine the result. If they are, it's a sum of those two parts, and you have your result. That's what parallelism would come really handy. And let's say we're trying to develop the app, but here we have Jenny, and Jenny is ambidexter. Ambidexter are people who can use their hands in parallel. So she can actually code and drink coffee at the same time. And here you have two cores. She has basically two cores, two CPUs. She can drink coffee and code. And at the end of the day, you have two tasks completed and you have developed app, but she will be able to do it physically at the same time. And it's like a stretch and it's very unsafe, but some people do it. And so the asynchronous form of concurrency, of multi-threading, it would be, see, I should have changed the heading, so please do not blame me for that. But I'm at fault. It should say asynchronous, but it follows this pattern of fire and forget for the most part. It's when you fire a thread and you're really forgetting it. You don't think of its result. It doesn't affect your main procedure. Imagine you're going for withdrawing money at ATM. And when you withdraw the money, the main process is give me the money. But as soon as you log in your username and you're in the system, the ATM might fire a request like Splunk or some logging service to log that the operation happened. It fired that event, and whether it logged it or not, whether the Splunk instance is up or not, it doesn't really affect the user who's trying to withdraw the money. That's what fire forget pattern is. It's non-blocking, as I said, and it does require multiple CPUs. So again, developing an app, you have, in this case, you came back to Henry, and Henry is a single CPU person, but now he's actually asking, where does the coffee come from? Who makes the coffee? And it's John. John was the person who was making the coffee. And so while Henry is focused on developing an app, John has been asynchronously just bringing as much coffee as he could possibly do. And so it's again, that one I think is quite a stretch to try to describe it, but that's the best way I could connect it to the main idea. All righty. Enough with abstractions, enough with the theory. Let's do some practice and look at the concurrency in Java. So concurrency in Java. First, they were runnable in threads. These things is what most of us encounter when we initially touch on the concurrency with Java. And so when it comes to runnable, just to refresh it, they take no input, they give you no output, and they throw no exception. I don't know why my slides are lagging. It's always a problem with Google Docs. And they don't throw any exceptions. Some people call them selfish classes. But ultimately, example here again, drinking coffee, you might say I'm obsessed with that, but I'm a developer, so it's a common thing. So anyways, you can see it has a run function method that you have to override, and you specify a process there. Anyways, I'm sure you've seen it before. Threads are a bit more complex. They're runnable based, so they do use runnable. Always at least one main thread in the app. And you can see that the thread takes runnable again overrides run method. And if you actually just invoke the runnable, it doesn't do much. But if you start the thread, it actually triggers the thread. So nothing really special, nothing new here, but that's really what people usually see. And if you work raw with these two classes, it might sound complex, and it is complex actually. Because and they also have to keep in mind the creation overhead. Creating new threads and managing them is extremely complex. So then we were lucky and JDK5 was released. And that's where we welcomed the Concurrency API, a major overhaul and changes. It has lots of things, but I'll touch bases on a couple. ThreadLocal, great class, atomic operations, thread safe collections, and there's a lot more. So let's look at one by one at these 3 great additions at least. ThreadLocal. Oh, ThreadLocal is amazing. So they do resource confinement. They basically create an instance of a resource for your thread. Why is it lagging again? Okay. So again, back to our simple date format. That's how you would encapsulate it in the ThreadLocal. And when someone tries to, you can see that I'm overriding the operation for the simple date format. And every time someone accesses the simple thread, the ThreadLocal, and does get and then format the date, it creates an instance for the thread that accesses this operation. You can already see how, again, you didn't have to write much, complicated code here and locking this operation for every thread, instead of creating a new instance of simple date yourself. Instead, ThreadLocal handles it for you. It's still, there's obviously some issues with that. It can prompt to memory leaks if you have too many of these resources open and never close them. And also it kind of encourages these global fields to be edited, like date format helper, if you edit as a global to your class. It's just generally not a good pattern. The more the global fields you have, the worse it is in terms of concurrency. Atomic operations. Atomic operations, they are basic compound operations. To give you an example, after it actually shows something on the slide. Okay. Basically, if you have, inline increment, right? I don't know, if you're talking about for loops, I++, if you create a variable I, I++, it sounds like it's an easy thing, but it's actually 3 operations at once. It has to get the value, it has to add the 1 to existing value, and then assign back to I, or to the variable. It's 3 operations. If you have 3 operations, it means that at any point in one of those 3, another thread can come in and change something. It can change I twice. It can change the variable completely. Things of that sort can easily happen. And that's why those compound operations are tricky to manage. And we have atomic operations in Concurrency API to deal with it, because they give you higher speed to actually work with them. And they have at the back compare and swap process, which we're already gonna dive into. What it looks like is, again, let's look at atomic long. If you have a long variable and you wanna just add it and increment it by 1 and get the value like you would do with I++, you can see that that's how you used to do it in a not thread safe way. That's how you do it with atomic primitives. The more complex objects for atomic operations, and it can be quite handy if you are switching context, for example, for, I don't know, trying to take snapshots. Alrighty, so in terms of thread safe collections, in particular, I'll touch bases on concurrent hash map. I think that one is, the hash map in general is quite popular, I would say. And so concurrent hash map obviously comes in handy. So again, it still touches bases on compound operations, because if you try to check whether the collection has a value and then put that value back into the collection, if it's not there, it doesn't happen in one operation. It's multiple, so it's prompt to not thread safe issues. It gives you higher speed, and it's actually highly configurable thread safe collection. So in terms of hash maps, you would generally have, let me move this thing, generally have capacity and density as a configuration. Let's say you try to count how many times the process was invoked. In the concurrent environment, you would have synchronized keyword, which is actually not that great, because it basically blocks any threads from accessing it until another thread finishes this work, which is kind of counterproductive for majority of cases, and it's actually complex to write. And so concurrent hash maps deal with that perfectly, I would say, because basically you have you have potentially better configuration. You can specify how many threads you're expecting to work with, and the only thing you need to do, you don't need to use the synchronized keyword anymore. You basically put if absent. There's a great method for that, and you can also use it in combination with atomic integer or atomic operations that I've mentioned before, and have a fully thread safe process without actually using synchronized keyword at all. I do apologize for jumping back and forth with slides. It's kind of lagging. I don't know, Google Slides always betray me. All righty, let's look at the asynchronous coding a bit. So where do we start with that? With the workflows? Obviously, I have to bring up promises in JavaScript really quickly. Featuring Callable, it's what we had initially in terms of kind of partial workflows, partial asynchronous coding, and then Executor Framework, which was a great addition to Java language, and then CompletableFuture. Alrighty, promises in JavaScript. So I'm not sure if you've heard, but the web developers would always bring up the callback hell that they still dealing with. Lots of legacy code in there, but it is extremely complicated. It's extremely verbose and it's not intuitive. You know, it's basically, we have these extremely complicated A, B, C, D operations that depend on each other. When it finishes, only then it can grab the result and use it. It's awful. It's hard to write. It's hard to maintain. I don't want to dive into that. But how do people try to fix it? They created promises. And not to say they created promises, obviously, almost everything in modern coding existed before, just reused. But anyways, still giving them credit. Imagine you had this kind of a fix a bug operation where if the result was successful, you invoke on success operation. If it failed, you invoke on failure, but you have to pass both of those operations in. It is, again, it's kind of a counterintuitive. You can see that it's basically invoking the operation that way. You send two functions into another function. It is tricky, really. Tricky to write, tricky to understand. instead with promises, they were able to create this kind of stream pattern where after you finish the one operation, like fix a bug, then it takes that result and brings it over to the next operation then, and if it failed, it does starts it again. If it succeeded, it goes home. So great. I mean, by it, I mean the person who fixed the bug goes home. Otherwise, he or she starts again. All right, yeah, that's what basic promises were. Very easy. I'm not going to dive into JavaScript here. It's not about JavaScript. The more importantly is the future in Callable. So what Runnable was for the thread is what Callable is for future. So when it comes to Callable, Callable is actually much better than the Runnable because it still doesn't take input, but it at least gives you output, and it does give you an exception. Let's say we're trying to say in the future, we're going to fix the bug. So we have this Callable. It has a method called call, hence the Callable, that you need to override, not run, call. It gives you a result that you specify, and it throws an exception, and you can, again, invoke something there. Much better. It gives you a lot more power than before. And that fix a bug situation, you would basically have that. You basically invoke the Callable here, similarly as you would do before promises came into play with JavaScript. Alrighty, for the future, more importantly, they are completed in the future, hence the name. Let's see. Okay, they do rely on Executor Service, Executor Framework, which I will touch bases later on, because they do require more discussion. But basically, just work with me here. You initialize Executor Service. Executor Service takes on this Callable. You basically invoke a method called submit on the Executor Service, and it does produce a future for you. As soon as you do that, it's basically it starts the execution of this Callable, and when it's done, it's going to produce you the value. Yeah, as soon as you call get on this future, it's a bit trickier than that. When you call get, it actually blocks the thread that it runs in. But anyways, if you let the future just run, it will give you the code eventually. All right, future might sound great, but it is not easy to use it by itself. That's why Executor Framework comes in. Executor Framework, it helps you with thread management immensely. It's amazing for that. It does invoke this, and I like to see that in Java more and more lately. I'm really liking it. It's basically, it forces declarative model where you are, instead of being imperative oriented, where you really want to know all nitty gritty details and try to manage everything by yourself. Instead, you focus on what you try to achieve instead of how. In this case, I don't care how Executor Service would manage my threads. I trust it. I trust folks who created it. I can configure it a bit, but most of the time I do trust it by itself. And so in terms of just small UML diagram, that's what it looks like. It looks fairly simple, you can say, but in reality, it's actually extremely powerful. It's all about thread pool. Thread pool is basically what does the thread management for you and what does thread configurations for you. You can see how many, six arguments. Ooh, that's a lot for a class, but fortunately, we don't need to initialize this class every time by sending 6 arguments, especially with some arguments being complex, like blocking queue and thread factory. Instead, we have factories, and that's why I really like the Executor Service a lot for. The factories that they have is a single thread pool that I'll show. I actually showed just a few slides before, but really it's I think it's best for experiments where you initialize your Executor Service. You first initialize a single thread pool, which means a single thread, which lets you to test your code, how it works with the futures and Executor Services. Then you can easily replace it with cached thread pool if you wanted to. Cached thread pool is best for scenarios where you don't know how many threads you need, and you don't really care if they die or live later on. A good example would be if you're creating if you try to scrap the internet, or you try to basically go in, create snapshots for websites. That's probably the best because you don't know how many URLs it might have. A fixed thread pool is best for some long-term operations. If you can do some algorithms or math calculations, you know exactly how many threads you will need, and you will let them work in parallel and then combine the results. It's best for that. Scheduled thread pool It's like a Chronos job. If you've heard of that before, it's basically, it's good for monitoring. If you try to monitor a service every once in a while, or ping something, ping a website, a scheduled thread pool is best for that. And also there is a more complex work stealing pool, which I think streams use under the hood. It's basically, it's a lot more complex thing. It manages the same kind of a pool of threads and just reuses them after one is done. So it's a bit, that one I'm going to dive deep into. But Executor plus thread pool gave us Executor Service. So it basically what gives us access to asynchronous tasks and the thread pools. Let's say we have a cross service. We initialize Executor Service using the factory that I just talked about. Then load it. Okay, then you have like a collection of URLs that you iterate through, and on every URL you trigger crawling, and so it's gonna crawl your website. In this scenario, you're actually never gonna get the result because you're not collecting them. Ideally, you would put these futures in the collection of some sort, and then after the fact, you will get the results. But when you call submit on the crawl service, that's where the process starts, and it triggers the scan. Are we done? I would say no, because the future is not perfect. I know it might be very abstract and applying to a lot of things, but in particular for Java, future had pitfalls. It's blocking operations. I mean, as soon as you call get, it blocks it. There is no result chaining. There is no future combination, and the exception handling is tricky. Blocking results retrieval, when you call get, it blocks it. So when you trigger submit on the crawler service and you try to call get, it blocks the thread where you call get on. And also here it has an exception thrown at you potentially. That's why you try to use a timeout if you have to use get, because you don't want to just have the infinitely stuck there. There is no chaining, so there is no real promises like in JavaScript. There's no real workflow. Let's say you have a fixed number of developers in a Kanban board, and you are basically programming a feature, and only after it's programmed, the person can test it. You can't really do it in line like you would do again with promises, right? You would have to do it one by one. You finish the code, you block yourself, then you have another block of code where you test the feature that was developed one by one. Again, it just makes the code verbose, and that's what we're trying to get away with Java as much as possible, because people already complain it's too verbose. And you even can technically do it in line of some sort. It's going to bring you to callback hell. Future combination is also tricky. There is an operation called InvokeAny and InvokeAll that's also blocking. For instance, if you're trying to find the location of the integer, simple scenario here, it actually shows me on the slides. All right. Again, you have the cache pool, and you cache thread pool. You basically trigger two different searches. You call InvokeAny, you block yourself. You can't really do it in parallel. Again, it's blocking. Blocking operations, I think, when it comes to concurrency, is always a thing that we try to avoid. Exception handling, that one I want to focus on more. Exceptions do happen. It's not if, it's when. And so with multiple exceptions that features cause on most operations, it's important how we deal with them. Let's say you try to log something, but the login service is down. You might have 3 different major exceptions thrown at you, and you have to deal with them differently. In some cases, you have to cancel on timeout. In some cases, you have to interrupt the thread. In some cases, you have to go deep in the execution exception itself and figure out what that might have cost. There are many issues, but fortunately, we have CompletableFuture to help us. And with that, we're going to get to CompletableFuture. CompletableFuture, it basically forces you to think of transformation, composition, and chaining, and also combination. And really what CompletableFuture is, it uses future, and it also has a completion stage. So it has everything future has and then some. And that sum, the completion stage, would basically allow us to deal with all the pitfalls that future had. Unfortunately, future and CompletableFuture are not compatible, really. You have to rewrite your code. So you can't just use the Executor Service for that to then bring to CompletableFuture. CompletableFuture has its own way of writing code, and I'll show it in a second. So If in future you had some pitfalls like blocking operations, no result chaining, no feature combination, and exception handling being complex, with completable future, we using transformation and chaining, for example, we're able to actually bring in workflows, the real asynchronous coding. And it also at the back it uses for jump pool, which doesn't really matter for this presentation in particular. But let's say you have a developer that codes non-stop. Then with completable future, what you can do is that you, instead of a person just waiting on the coffee, let's say a person goes to grab a coffee, instead of just going and waiting at the machine, the developer continues to code. They have a machine near them. They press the button by invoking this completable future that supply async, basically trigger an synchronous operation, and the coffee maker is going to brew it for them. So they don't need to do that. They can continue coding. And then when the coffee is done, only then the developer goes ahead and drinks that coffee. So this operation, the supply async, doesn't actually block the developer and stops him or her from coding. And there's a more complex ways to run it as well. You can supply your own thread pool, but again, it's overkilling it for this presentation. Alrighty. The task composition. The task composition, again, it forces us to think asynchronously. Again, in this case, it basically acts like a flat map and compared to supply async. So for instance, let's say you are developing a program and developer writes a program, codes it, whatever word you want to use. And then you have a tester who tests that code. So it's two separate operations. So the kind of a complex way to deal with it is if you do develop program, then you call then apply. So after the program developed, then you invoke the test program. But that actually would be complicated because test program returns a completable future. And that basically gets you in a very verbose code and almost like completable cal looking code. Instead, because you have, let me remove this so it doesn't cover it. Actually, let me hide it completely. So yeah, instead, what you do have is something that acts like a flat map. If you dealt with, let's say, streams, you invoke then compose on the first result, on the first completable feature of developed program. Then after the program is done, it's going to supply it to test program, and test program returns completable feature of its own, and so on and so forth. So really, they really thought it through. So they try to think of developer experience here. And it's already built in completable future to make sure you don't go into like depth of completable future, of completable future, of completable future. Instead, you have results at hand. Okay. Controllable futures. Futures are controlled now, which is great because they are completable, meaning you can complete them if you wanted to. Let's say you, again, making coffee and you want to make a latte. A latte is basically like it's espresso and some milk. Very simplifying it, but let's say that's the gist of it. A few options here, right? You can either not waiting until the operation is done, and you can just say, give it to me now. Like whatever you already have, just give me Americano. Like add some water to espresso and I'm done. I don't want to wait anymore. Another scenario, you can also call complete method, meaning that if it's not done yet, just complete it, just give me espresso, give me whatever you already have with this default value, espresso in this case, and give it to me. And I'm going to take it and everything is done. The process is done. So you have a lot more control here. I know, again, it's quite abstract, but I feel like it's a lot more fun than, look into like real cases. Mutable futures you can control without blocking operations. I think it's very powerful. There is an operation called all off or any off. Yes, great scenario. Let's say you have a WebDriver tests, and WebDriver tests, you want to run them for multiple browsers, Firefox, Chrome, Internet Explorer, and more, right? The only thing you have to do is basically all off and then send asynchronous operations for different browsers, and you're done. It's going to invoke them and run them asynchronously and then give you, in this case, it returns you void because that's what it does return. You can actually collect these results one by one if you wanted to as well. But again, if you're just using it as is, results are not really formatted. So it does has its complications, but at least it's not blocking compared to Future itself. And if you can basically check if they are done, which can be good if you're building like a dashboard, for example. You can see how many failed, how many are still running. It's quite powerful. You can also combine tasks, collect results, and run them synchronously or synchronously. Let's say you have real scenario where your team providing APIs, and there is a team A that asks you to build an API, and the team B. Instead of working one by one, you're waiting for both of them to file the requests. So use then combine. So A and B file the request, and only then you proceed. Request A, request B, and then you have a plan that you produce. You basically connect with your team and discuss, evaluate those requests, and prioritize them. Real scenario, really, but then combine is very powerful. Exception handling, I think that one is the best one, because it forces you to gain to, even though it's asynchronous programming, you can think in a sequential way, like you would do with try-catch workflow. Let's say you scroll a website, but the website is down. And so you have exceptionally function to invoke. Exception is basically, if there is a throwable, it will, you can either lock, you can return, so you can recover. There is also handle. It's like finally. So exception, it only will go if it failed. Had an exception handle, it will always go in. So if your throwable is null, it means it did fail. If it didn't fail, then it's basically, nothing to do really. And you can just proceed. So it basically works like finally. So I think it's really great because again, it brings you back to sequential way of thinking. And the less complex you can make concurrent coding, the better I think it is. So I've talked about a lot of things. My call for action here is that if you avoided concurrency like I did before, I know it's since changed. I mean, I'm here talking up to JDK9 basically. It's since changed greatly, and people are now talking about reactive coding, and there are more things in the works right now. But more importantly, of course, is the try to avoiding a concurrency and try to use it a bit more if you can. Review your application. Maybe even if you're not writing concurrent code and you're not thinking about it, at least design for concurrency. It will always be beneficial. And continue learning. As I said, there are things that are coming. The Java has been changing quite rapidly, I would say. So yeah, that's about all I wanted to say here. We'll go to Q&A, and if you want to talk to me afterwards in any way, go to Twitter. Probably the best place to reach me on my blog, where I'm currently rebuilding, LinkedIn, or email me directly if you have any questions. So thank you, everyone. I appreciate your time, and let's look at chat. Maybe we have something. Actually, can I stop sharing? Stop sharing. Let's have my face there. Okay, good. All right. Oh, my chat is big. Okay, Baby Shark. Okay, I like that people appreciate Baby Shark. Okay, anybody else have freeze? Oh my. Okay, works on my machine. Works on my machine is usually the best phrase people can say, especially with testing. Okay, works fine. Thanks for the info. All the time. It happens with legacy systems. I wish I was reading the chat as I was giving a talk. Okay, I think being a new father also requires coffee consumption. Okay, good. Yes, yes, it does. I have this great mug. Oh, jeez. Oh, the virtual screen. It basically says new data established 2020. Anyways, okay. Let's see. Asynchronous await is also nice. Synthetic sugar around promises. That is true. But I personally, it just looks. I want to say it looks ugly. That you have basically operations just at await async, await async. Yeah, but it's how you deal with JavaScript. But it's better than what they used to have. Okay, when having an unbounded thread pool, could it lead to unexpected loads? Unbounded thread pool, meaning that there's no limit. Oh, let's say there is no. Let's assume that it means no limit. It's unexpected load. Technically, yeah. I mean, yeah. It's always good to have a limit of any kind. I think there is a built-in limit. I'm pretty sure there is. I don't remember the number actually, but because you have to supply, I think you have to supply a size, even if it's in a factory, and I think they do supply it, but it's always that's a good question. I actually don't remember exactly how they do it, but yeah, if you, for instance, if you say scan as many URLs as possible and you trigger too many threads, yeah, you can basically blow up the machine to some extent. So I'm sure that's definitely a consideration to think about. But I believe you can specify, you can supply the maximum threads, and there is definitely something built in, but I don't quite remember actually. But that's a good point. We always have to think about it. All right, another word. There was another word. See, I don't read. Would it be advised to always have an upper bound for maximum number of threads? That is true. Yes, it's always good to have a maximum number of threads that you can. But even then, it always depends on what you can manage. Usually, I like that people usually do these sorts of things in. Oh wait, that means that people do these sorts of things with the maximum of threads in the config file. So depending on your environment, like if it's prod or it's a UAT or it's test environment, you can set the upper limit depending on that. So I think usually those things are configured in a config file of some sort. But yes, it's always a good idea to have a maximum because yeah, it will blow up at you. Simple reminder, okay, 5 minutes left, that means okay. How do you convince developer not to use threads and monitors anymore and turn to CompletableFuture? It's like, you don't need to convince developers really, you need to convince their manager. But no. I'm actually very much, if it's not broken, don't fix it. Usually the best way to deal with things or change it in organization is to measure how much time you spend, because nobody can argue with real numbers. People usually never argue with numbers. So look at how much time people spend in debugging and dealing with issues that caused by the code they currently have. And if you can prove that the CompletableFuture or something actually else can fix those problems, compare it, and see, give those numbers, give those basically that hours spent to your management, to your team, and also make sure that you present the solution by saying this is the ways to actually learn about it. And there's quite a few materials out there about CompletableFuture and other things as well. So definitely think about numbers, hours spent. It's the same. It goes the same for tests, right? You look at if a test, you spend more time fixing the test than you fixing the code that test's supposed to show issue with, you probably need to remove the testing code. It's the same for anything really, even the concurrency. Please explain more about then compose async. Okay, let's see. Let me quickly check. Let me see what I had. Then compose async. Let's see. Probably was at the very beginning and I skipped it. Okay. See it. Okay, let's see. CompletableFuture. Let's see it at the beginning. Then compose. Let's see. Okay, then compose sync. Oh, I didn't give an example of that. Oh, interesting. Let's see. Did I give an example of that? I don't remember. Executor. So if you, I think, oh yeah, I'm pretty sure. If you do that, it's basically it uses a different pool from the pool others use. That's what the executor, the next argument is for, because the executor is basically a factory that creates the pool. Unless you want to initialize your own thread pool, it will actually use a different pool from what you used before, if it makes sense. So by default, it uses, I think it will use fork join pool by default. Yes. And if you actually supply your own, it will use a different one. So you can specify if you want to use a cached pool, if you want to use a limited number of threads. I believe that's the case. Again, I haven't actually used that one as much because that one is it's a bit more complex. I'm always open to admit that I don't know things, but in this case, I've used very partially before when I had to actually have a limited number of threads, but usually I don't utilize the functionality. How do you deal with CompletableFuture all off when you have a list of completable futures? Have you found a better way than just convert to CompletableFuture? I think last time I had to deal with it, I was, yeah, have a completable feature array. It's one way to deal with it because that's what it accepts. I only found, I think I've seen, what's his name? There is this person who wrote a great tutorial about completable future. Let me quickly check on my completable future. Yes, Baldun, B-A-E, actually, I'll link it here. I found his tutorial. Oh, interesting. How do I? Anyways, I'll put it. Yeah, Baldun, BAELDUNG.com. You probably know him, and he's been writing a lot about Java. But anyways, he actually, I think, covered this all off, and I'm pretty sure some of his tutorials he used something more complex than just an array. But yes, I used array myself in the past, again for collecting the results because that's what it accepts all of. But I think there is a way to somehow do it as a map. But yeah, it's usually arrays is probably the easiest one. But yeah, I also don't like arrays. Some advice for logging apps when use concurrent and parallel techniques. Sometimes it's hard to know what is going on. Yeah, the important thing with logging, when you do the logging, make sure you name your threads. I believe when you're working with threads to begin with, even the thread pools, you can name your threads. Make sure they are descriptive enough so you know exactly what you are logging, what thread the issue is happening in. So that's really about all I can advise you with, other than the techniques that you might be using for logging. But as descriptive as you can do, maybe also specify the severity of those, the priority of those threads. But yeah, try to be as descriptive as you can. That's really, I think, the first thing you will need to do when it comes to logging. Will your slides be available to share? They are available, actually. They are on the slide share, and you can find them on my website. So you see them. Here, here, go here. It's not the greatest website, but I did just move to Gatsby or something recently. So you'll find one of my talks called Completable Future way below other talks, and you'll find slides there. You mentioned the compatibility issue with Future and Completable Future. Any tips on this? Yeah, you can't. I mean, you can, the code that, technically speaking, you can say callable, the code inside of Future, you can grab and plug it in Completable Future, but you do have to, you can't use the Executor Service the way you would with Completable Future. So thank you for linking. Yes, that's what I mean. That's what I mean for the slides. Thank you. It has like link to my slide share. Sorry, back to this point. Yeah, compatibility issues. So you can't just replace Executor Service with Completable Future and expect it to work. You have to rewrite it. But technically speaking, it's all a shell, whether it's a future, whether it's a thread, whether it's anything really, even Completable Future right now, maybe it changes later on, right? Make sure you separate your logic, the logic that you are actually invoking. You might have seen that I've never actually written in these slides, I've never written code inside of Completable Future. It always was written in its own method that I then supply to Completable Future to invoke. And that's how, you strive for a better abstraction. That's what design for concurrency means. So really, there's nothing with compatibility I can advise here. You just always prepare for the change, especially with Java changing so rapidly. I think there's a project Loom coming up, which I've actually haven't read about at all, but it also deals with concurrency and asynchronous, I believe, coding. It's game changer, they say, which I have not dived into. Yeah, thank you for linking the Completable Future tutorial. Definitely is a good one too. 2 minutes we have to cut off. Oh my God. Oh, did they cut me off? Oh. You're welcome. Okay, people linked. Okay, there are no questions left. Thank you so much. Please do ping me on Twitter if anything. I do appreciate your time, and have a nice day, rest of your conference. I'm not sure if it's end or for me it's 9 a.m. Pacific. So thank you everyone, and yeah, enjoy. I'll see you all.